Hello students, this is video 7.12, unit titled Circular Art and Spirals. Your objective is, I can determine the measures of angles, arcs, and lines formed by secants and tangents. Okay? Notice there are no IXL skills because we are still reviewing for our unit test B, which is Friday. Alright, let's go flippers. So, first thing we need to talk about is these few circle theorems. Okay? So, we're going to work with some circle theorems today that you've seen before. But for these circle theorems, they are used for finding arcs and angle measures. Okay? And the first circle theorem says the difference of two intercepted arcs divided by 2 is equal to the measure of the angle formed by the tangents and or secants. So let's actually draw that. So the difference of the two intercepted arcs. What I'm talking about when I say intercepted arcs is you create. So this is an arc, 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 this is an arc. And you create those by drawing in secants and tangents. So you can see this secant and this secant, and here's a secant and a tangent. Well, we're creating these arcs by drawing in these secants and tangent lines. And what we also create when we draw these secants and tangent lines are angles. Okay? And I want to highlight the angles that we're finding. So here's an angle. Here's an angle. Here's another angle. Okay? This theorem says, and we're going to use this example as we work now, this first one. Okay? This theorem is saying the difference between the two intercepted arcs. So here's an intercepted arc. So we'll say arc RT. And arc RT is the bigger arc. If you look at it, it's bigger here. Okay? The difference between the two, so the other intercepted arc is arc SV. So we're going to take the difference, which means we're going to subtract the measure of the two arcs. We're going to divide all of that by 2. That's going to be equal to the measure of, so let's name this over here C, angle SCV. Okay? So that's what that means. So let's do that for the other two examples. Example is very similar to the one we just did. It's two secant lines. So again, we're going to write this out. We're going to look at our major arc, the bigger one. So here's our bigger arc, and here's our smaller intercepted arc. So we'd actually write the measure of arc MO minus the measure of arc BU. All of that, again, divided by 2. So now I'm going to put 2 downstairs so we could cross multiply if we needed to do this. Is going to be equal to angle BNU. Now the same thing is true for the example next to us. Even though we have a tangent and a secant, it's still true. So we're going to actually write out the bigger arc. And if you look at it, you can see QU here is bigger than LU. So we're going to say arc QU minus arc LU divided by 2 is equal to angle LRU. Okay, now remember, all these theorems are for finding arcs and angle measures. So you might be given one of the arcs and one of the angles, and you have to find the other arc. You might be given both of the arcs, and you want to find the angle measure. And that's what we're going to work on in a few minutes. What I'm going to talk about is two circle theorems. And again, we've seen this before, but these are highly missed questions from the Unit 7 exam. Circle theorems where we're finding the segments. And there are 2 scenarios that you need to think about. The first one is tangent secant. It says the tangent squared is equal to the measure of the outside of the secant line times the quantity of the sum of the outside of the secant and the inside of the secant. So that literally translates to find your tangent, there it is, square it. So T squared is going to be equal to, and again it says the measure of the outside of the secant line. So here's my secant line. My secant line is all of this. But I just want the outside, which is going to be S. And then that is going to be times the quantity of, and that's what it says right here, times the quantity of the sum. So I'm going to be summing some, and the quantity of means I need to open up parentheses, and I'm going to be summing 2 things. Okay, because that's what it says here. Sum of the outside of the secant and the inside of the secant. So, I'm going to sum this outside part with this inside part. So that means I just write S plus R. So that's how I do it for that type of problem if I'm finding one of the missing segments. Now, that's for a tangent and secant. What about a secant and a secant? Ooh, it's really not much different, folks. It's really not. This time you've got two secant lines. So basically, the difference here is we're going to take the outside for secant, the outside of the first secant line. So let's label that. The secant line we'll focus on will be BD. And then our second secant line will be CP. So this theorem actually says you're going to take the outside of the first secant line times the quantity of the sum of the outside of the first secant line and the inside of the first secant line. So we've got our outside of our secant line, first secant line, times the quantity of the sum of the outside plus the inside. And that's actually equal to the same thing for the second secant line. So let's write that in. Have it, folks. C times the quantity of C plus C, P. So we're going to try both of these theorems. And remember, this theorem now focuses on missing segments. So what could happen? Oh, maybe they could give you S and R and look for T. Maybe they could give you BD and look for C. And also give you P. But remember, you're trying to find a segment. Question number 1 says, find the measure of angle SQR. So this is one of those problems where they're looking for an angle measure. They want to know how big which angle this angle is. So I know that one, before you do this problem, please change this angle up here to SRQ. That's the angle that we're looking for. So because this is an angle problem, I know they're looking for this angle. We're going to use our circle theorem for angles and arcs, which says that the major arc, the big one, minus the smaller one, the difference of the two divided by 2 equals that angle. So now I can fill in what I know. 140 divided by 50 minus 50 divided by 2 gives you 90 divided by 2, which equals 45, and that's our solution. 2, very similar problem, but this time they want to know the measure of the arc, but it's still an arc or an angle problem, but they want to know RB. So we're going to use the same strategy. We're going to say here that arc RB minus arc EC divided by 2 is going to give us this angle here. So let's plug in what's given. Plugged in everything that was given to me, all the measurements for RB, for EC, and then for D. And now this is an algebra problem I need to simplify and solve. Just combining those like terms. Now I'm going to cross multiply. Multiply. Now I want to collect like terms to add 53 to both sides, which gives me 3x equals 33. Therefore, x equals 11, and that's what I was originally asked in my problem. What is the measure of RB? Remember, RB, if you can see up there, is 13x plus 7. So I need to take 13, multiply by 11, and add 7. And I'm going to end up with 150 degrees. Example number 3 says, find the value of x. Look at this question. This is a circle theorem that's asking you for the measure of a segment. So now we need to use our circle theorems for segment measure. And we need to identify if we have a secant and a tangent, or tangent, a secant and a tangent, or a secant and a secant. Looks like a tangent and a secant to me. Therefore, we would say that the tangent squared is going to be equal to the outside of the secant, which is x, times the quantity of the sum of the outside plus the inside of that secant line. Now let's plug in what we know. 6 squared, I'm going to simplify that to 36, equals x squared plus 5x. We've got to get everything on one side. Subtract 36 from both sides. You see we've got x squared there. So now we've got x squared plus 5x minus 36. This is a quadratic, young people, and we're going to have to figure out what two numbers, x factor, are going to multiply to negative 36, but add up to 5. It's 6 and 6. Wrong. 6 and 6, or even 6 and negative 6, might multiply to negative 36, but they don't add to 5. So let's try again. What about 9 and 4? Here's 9, here's 4. If I make 9 positive and make 4 negative, I'd get a negative 36. And if 9 minus 4, you can get 5. Those are our factors. So we're going to have x minus 4 and x plus 9. Now we know one of these is our answer, okay? But you have to solve these little mini equations. Whichever one becomes positive is your solution. We found it. We add 4 to both sides. X is going to equal 4. The other one won't work because when you solve this, you will get a negative number. So our answer is 4 big ones. Start with our secret hot question. It says, drum roll please. It says, find the measure of TR. So you need to find this whole measure. What type of problem is this? Is this a circle theorem we're really looking for an arc or an angle? Is this a circle theorem we're looking for a side measurement? Figure it out. See you tomorrow.